Does the composition of other planets seem to be very different? Is it just layered differently, or are the minerals different? What can you say safely is the same and what is different generically?
Yeah, I like to compare the different planets in the solar system, kind of like comparing members of a family. They have some similar genetics, but not exactly the same, right? So the rocky planets, for example, we all know that they're dominated by having magnesium silicates and some amount of iron at the center, but the relative amount of iron to the magnesium silicates can be quite different. Mercury has a huge iron core and very little rocky magnesium silicate layer above it, whereas Earth and Venus seem to have a similar amount. And Mars, too, seems to have a little bit more than Earth and Venus relative to the size of it, but not so different. The Moon, on the other hand, has very little iron in the interior and is mostly just a rocky planet with a very small core.
Again, mineral composition, is it very different, or you can really only tell very, very generic type things? Like, I guess in the Moon, we've gotten samples back. Has that helped inform anything about, I guess they call it regolith, the surface? Does that tell you anything about the inside?
Yeah, so the actual amount of minerals is pretty similar on all these bodies, right? There's certain amounts of magnesium silicate, certain amounts of iron. They might slightly different percentages, let's say, of even or less common minerals, right? There might be slightly different amounts of sulfur in certain bodies, amounts of oxygen, things like this. That all sometimes depends on the conditions that the planet was formed in, right? So different temperatures at different distances from the sun can affect how chemistry happens in the rocks, right? So all of that matters, but they're all small differences, right? Now from the Moon, these samples we've gotten from the Moon, that's actually told us a lot about what the Moon rocks are. And the amazing thing about it is that we've learned that the Moon is essentially made from the same stuff Earth is. So this is really kind of makes sense when we think about how we think the Moon formed. We think proto body, something about the size of Mars slammed into Earth in its very early history and ripped off a bunch of the surface of the Earth as well as the proto body that hit it, sometimes called Theia. And that material formed a disk around Earth, which eventually coalesced into the Moon we have today. So the material in the Moon used to be material in the Earth.
Interesting. What other planets do we have much or any knowledge about? Anything on the further out ones, Neptune or Jupiter, any of that?
Yes. So we have sent missions to all four of the giant planets, Jupiter, Saturn, Uranus, and Neptune. And they've told us a lot about those planets. And right now, the Juno mission is at Jupiter studying its interior by doing gravity and magnetic measurements. And what we've learned about the giant planets that's really interesting is we thought initially that we understood how they layered on their inside. We thought there was probably going to be like a rocky core at the center and then a huge hydrogen gas layer surrounding it. And it turns out that it's not that straightforward. The rocks in the deep interior and the hydrogen seem to be mixed a lot more. And so people are now talking about what we call a fuzzy core. So there seems to be almost like a dilute immersion of the rocks and the hydrogen. And again, that's because the high pressures down there and the high temperatures change how materials interact with each other and behave.
Any planets we've looked at that just are like a bewilderment, or they're really, really strange, at least from initial measurements?
Personally, I think all the planets are strange, but that might be my own perspective. I think there are some really fascinating planetary bodies out there that we want to go learn a lot more about. One of them, my favorite to talk about, is Titan, which is a moon of Saturn. And Titan is really interesting because it has a very thick atmosphere like the Earth does. And it's a nitrogen-based atmosphere like the Earth has, right? And the surface of Titan, the pressure there is fairly similar to the surface pressure on Earth. It's about 1.5 Earth atmospheres on the surface of Titan. Now, what that means is that the conditions are just right on Titan for there to be liquids that flow on the surface. So Titan has seas, it has rivers, it has mountains as well. Now, the catch is those seas and rivers aren't made of water. They're made of hydrocarbons, things like ethane and methane. So it's a different liquid that flows on the surface of Titan.